Good afternoon, ladies and gentlemen. My name is Godnos Nyandoro, and I'm going to present my project called JV Cardio AI. Uh, it is under this cardio risk classifier project which we presented as group earlier. So I am from the Department of Computer Science. Under the faculty of Computer Engineering and Informatics. I am being supervised by Mr. Mulambo. So I'll start by explaining the background of this project. So the purpose of this project is to allow the doctors to do the diagnosis of the heart disease in the patients. So this means that this system is strictly for doctors. It allows the doctors to enter the symptoms of patients. Then it will do the predictions using the machine learning algorithms. So that means we train our model using machine learning models. So I'm just going to show you the page, the machine learning page just showing you how we train our data. So I'm just going to scroll down to show you how we train our data. Uh, then after training the then after training the data, uh, then after training the data, we deploy the module to our system, which we developed using Django, which is the system that I'm going to present to you today. So now let's jump to our Django system. So on our Django system, this system we have a strong authentication, which allows the doctors to create a new account or to log in as the existing users. So now I will just, for this demonstration, I will start by creating a new user. So let's just create a new user. So let's just say the doctor name is John. Is John. Then last name is Moti. Then username is John. Then email, let's just put a dummy email with at gmail.com. And then the password, let me just put a password. Let me just put a password 1, 2, 3, 4, 5, 6, 7, 8, 9. A password which is easy to remember. Then hit the sign up button. Then after signing up, you will see that a new user have been successfully created. So let's log into our system. So I will just enter the name John, username John, then the password that 1, 2, 3, 4, 5, 6, 7, 8, 9, then log in. Then after logging in, we have been led to a landing page, which is the main page of this diagnosis system. So our main page is the diagnosis page. As you can see, if I refresh the page, you just see that the landing page is the diagnosis page. So this diagnosis page allows the doctors to input uh, patient's symptoms or patient's data. After inputting those patient data, that data will be used to make the predictions, right? So the doctors can input the data in two formats. It's either they will use their voice to input the data, or they will use the keyboard. The use of two inputs is crucial for time saving, especially that voice input is time saving and it is simple to use. And also we have another page called report. After the doctor input all the data in the diagnosis, they will be redirected to a report page showing the prediction results, showing the prediction results. Uh, this page will show will show the presence, either the patient is suffering from a disease or the patient is not suffering from a disease. And also we have another page called review. This review page allows the doctors to make reviews uh, based on the diagnosis, based on the results, the results that have been predicted by the system, and the actual results they've been found out. So this helps us, the developers, to improve the system, to improve the efficiency of the system, or to improve the model accuracy. And it also helps us to use the Zimbabwean data, because as we mentioned earlier, that we use the UCI repository data to train our model, which means we use the data from the countries which are not in Africa. So now, after the reviews, we will retrain our data using the reviews of the doctors, making sure that we are improving our system each and every time. And also, the beauty of our system, let me just go to our report. For now, we see we have recently added this doctor called John, and so far John have not do any diagnosis yet. So that's why you are seeing this report page empty. There is no any patient that have been diagnosed yet, and also the graph is empty. So if so, I'll just explain those things after doing the diagnosis using this doctor. Then also we have this review page. So this review page, on this table, they will be displayed the information of the patient that are being that needs to be reviewed, right? So far, there is no any patient which needs a review, right? And also, there is a graph showing the overall statistics, the overall review statistics. This graph shows how many predictions were correct and how many predictions were wrong. It helps. It helps the users or the doctors or the new doctors to have the full trust on this model, right? So let me just start the diagnosis. So I will do the first diagnosis using the text input, and I will do another diagnosis using the voice input. Then I will use the data which I have in my phone that I collected from the UCI repository. So let me just do the prediction. Let me just do the diagnosis using the text input. So let's just say the patient name is uh, God knows Nyandoro. And then the age, according to the data which I am using for this patient, for this patient, we are expecting a negative result, which means this patient should not be suffering from a heart disease, right? So let's just see if our model will make a correct prediction. Just mark my words. This patient should not be suffering from a disease, right? So let's just see if our system uh, makes the correct prediction. So the age of this patient is 74. Then chest pain type, it's a typical angina. Then then the resting blood pressure, it's 120. Then the cholesterol level is 269. Then maximum heart rate is 121. Then then the exercise induced angina. Uh, yes or no. But here for this patient, it is yes. Then old pig, it is 0.2. Then the slope, is upsloping. Then number of colored vessels, is 1. Then the thalassemia, it's normal. Then let me just hit the submit button and see if the prediction is correct. So as you can see, it is showing us that patient data saved. Then this is the diagnosis report for Godnose Nyandoro, and it is showing the patient details. And let us just jump to the prediction. Then the prediction is no heart disease. That means that our machine or our system have made the correct prediction, right? So this is the correct prediction for the patient with the data that we entered. And also we have another statement here: review status not yet reviewed, right? So that means this patient have been not yet reviewed. So as you can see, the diagnosed patient on the diagnosed patient, we have a new list with uh, only one member, which is the patient that we recently diagnosed. And also the graph is showing 100% healthy patients and no any diseased patient, right? So our system also allows the users to print this information or this report, and it also allows the user to download this report as a PDF. Let me just do a demonstration, just trying to download this PDF. So as you can see, the PDF has been successfully downloaded. You've been successfully downloaded. It is here. So I'm just going to delete it. So the PDF have been downloaded. So it is very it is a user-friendly system. Uh, so it means that the doctor can just share this report to the patients, and also our system can send the email to the doctor showing the same report of the patient. So it means that the doctors can resend that email to the patients, or should can just know the diagnosis uh, when it, even if they are not logged in on the system. And also, let's just go to the reviews and make a review. So I will jump to the reviews. As you can see here, as you can see here, uh, as you can see here, uh, a patient to be reviewed have been added. So here are the recently added patient have been is waiting for a review. So a doctor can make a review. So let's just say the prediction was correct. So for this doctor, let's just say he do some further analysis and find out that the prediction was correct. Then he will just click this submit button. After submitting, you see that there is no inpatient to be reviewed. So a message has been displayed showing that review update successfully for Godnose Nyandoro. That means there's no any diagnosis that is being there's no any review that is going to be carried out. And also you can see on the graph shape has been changed, and also number of correct prediction have increases, right? So let us just do the diagnosis using the voice input. So the voice allows a dialogue, like, right? So the system can ask us a question and we can answer a question. It's either we can answer it using a voice, later on editing that system. So let us just do another input. using the
What is the
voice.
patient's name?
So the system will ask us what is the patient name, and I'm going to say the patient name. And also, for this data, I have this data, and for this data, this patient should have a positive result, which means this patient should be suffering from a heart disease. So we just want to see if our system gets uh, the correct answer. So I'm going to say the patient's name. Nico Stole. You see, the name of the patient have been inputted on this input, right? Then I will go to the next question.
What is the patient's age?
77. 77. 77. 77. 77. As you can see, the output has been come. It's because of my CPU. That's why it is taking too long to respond. So I'll jump to the next question.
What is the patient's chest pain type? Typical angina, atypical angina, non-anginal pain, asymptomatic.
Asymptomatic. Asymptomatic. Next
What
question.
is the patient's resting blood pressure in mmHg?
125.
What is the patient's serum cholesterol level in mg/dl?
304. 304. It is because of my CPU and the performance of my PC which I'm using, but this is working efficiently. 304. The next question.
What is the patient's maximum heart rate achieved?
162. 162.
Does the patient has exercise-induced angina? Yes, no.
Yes. 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 Yeah, it is because I'm running so many systems. So my system, my laptop is performing very slow. So let's just move to the next question.
What is the patient's old peak? ST depression induced by exercise relative to rest.
Next
What is the
question.
slope of the ST segment? Upsloping or downsloping or flat.
Upsloping. 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 Upsloping.
How many vessels are colored? The values should be between 0 and 3.
3. 3.
What is the patient's thalassemia result? Normal, fixed defect, reversible defect.
It's normal. So after inputting all the data, it will give us the summary of our responses. After the summary, there's a submit button. Then I'm just going to hit this submit button and see the report. So as you can see, there is an error that we make here on the thalassemia values. We should check a spelling and input again. So let me just, as I've demonstrated how the voice input is working. So let me just use the text input, which is a bit faster. So let us just use another name, Tanaka. Then this is the patient name. Then age is 77. Then then the chest pain type is atypical and is asymptomatic. Then then the blood pressure it's 125. Then the cholesterol level is 304. Then maximum heart rate it's 162. Then here it's yes. Then odd peak is 0. Then the slope it's upsloping. Then number of colored vessels 3. Then thalassemia results is uh normal, right? So let's just see if the prediction is correct. Like I mentioned earlier, I said that the prediction should be the patient is suffering from heart disease. So let's just see if the result is that. So as you can see, the data have been saved. This is the report summary. This is the report summary for a patient called Tanaka. In Tanaka, I've noted, reviewed, and also this patient is suffering from a disease. Then there's a description or a recommendation. After that, there's two buttons, one which can allows us to print and download as a PDF. So that means our system is performing very well. As you can see, our diagnosis, our patient's analysis is showing that out of two patients that we diagnosed, one is suffering from heart disease, one is not suffering from heart disease. This is being showed by this graph. And also on the review, the patient that we have not yet reviewed is Tanaka, but we reviewed uh, the first patient that we entered. Let's just review and say that this prediction was correct. Let's just hit submit button. As you can see, the graph shape have been changed, and we have 4 correct predictions and 1 wrong predictions. And also, if you go back to the report and click Tanaka, then we will see that the report status is showing that the review status is this patient have been reviewed. So our model is working very well. So there's last thing that I want to show you, which is the user sessions. That means I just want to demonstrate the security, how secured is our system, right? So the patient information for Dr. John cannot be accessed by any other doctors, right? He's the only one who can access that data. Okay, so let me just log out as Dr. John and log in as uh God knows JV. We have another doctor called God knows JV that I added, and he have his patients. So let's just log in as God knows JV. So let's just go to the report. As you can see on the report page, uh, uh, we have uh, we have Godless JV patients, which are different from those patients that have been diagnosed by Dr. John. And the graph, and you can also see the graph shape. It is different from that one of Dr. John. And also the review status. As you can see, there are so many patients that have been not yet reviewed by Dr. Goodness. So let's just make a review for Mike Jackson. Let's just say it was correct. So as you can see, Mike Jackson have been removed from this table, and the correct predictions have increased to 5, and also the wrong prediction is still 1. So that's all about this system. Thank you for your time.